Okay, so last section we're going to look at this week, we're going to split into two parts. Okay, it's 3.5. This is same kind of idea that you did yesterday. It's still graphing. But now we're going to graph equations in slope-intercept form. What was the form that we used yesterday? Yep. Standard form. And when we want to graph something in standard form, you plug in what number?
0.
Yeah, you do it twice. Plug in 0 for which letter first? Well, it doesn't really matter. You got to do both. But yeah, plug in 0 for y, and then plug in 0 for x. That's the best way to do it, if it's in standard form. Well, not every equation is in standard form. Okay? Sometimes they use one form, sometimes they use the other. Just like people speak different languages, just different ways of really kind of conveying the same thing, just different. So, first thing we need to mention though, if we're going to do slope-intercept form, is what is slope? So on your guided notes where it says slope is, it's the rate of change between any 2 points on a line. That's the definition of slope. Rate of change between any 2 points on a line. Okay. What you're really measuring when you do slope is steepness. You are measuring how steep something is. Okay. Let's look at two different lines. Let me put 2 dots on each line. 1, 2. 1, 2. Okay. Look at dot 1 and dot 2. If you were standing at dot 1 and somebody else was standing at dot 2, is there that much of a difference in like the height between dot 1 and dot 2? I mean, it's a little bit, but is it a big difference?
No.
But not that much, a little bit. Right? The person standing at dot 2 is a little higher than you are. Their vertical change is like that. If you wanted to look at it. Now, let's look at these 2 dots. You're standing at dot 1. Your friend is standing at dot 2. Look at the change this time. Is that a bigger change?
Yes.
Yes. The vertical change here is much bigger. So when we talk about measuring the change, that's what we're measuring. What's the change? How much? It's bigger in this case. There's more change. That means the line is steeper. Here, little change. Very small. That means the line is less steep. Okay? So that's the change that we're going to measure. And when it's on a grid, we can count it. 1, 2, 3, 4, 5. We can count how many up we have to go.
How would you measure it if like it's not on a graph?
We'll talk about a formula you can use.
Okay.
Yep. I'm going to show you a formula. So there's different ways to find the slope. If they give you a picture, you can just look at the picture and count. If they don't give you a graph, then you got to use a formula. So we can find slope 2 ways. Okay, and I just told you guys the 2 ways. Okay. If you are given a graph, okay, when I asked you guys in the warm-up, what is slope? Somebody said this earlier. They said it's rise over run. Okay? Yeah, rise over run. So, just so people understand rise and run, this is rise. This is run. Rise is always vertical. Okay, if you've ever like helped somebody like put stairs in, when you put a set of stairs in, there's things called risers. The riser is the vertical part of the stair. The tread is what you step on. That's the tread. So there's the tread, and then there's the riser. The riser goes up and down. Okay? So in a set of stairs, rise is vertical. Run is horizontal. Okay, I can even write that. Rise is vertical. Run, horizontal. You can't mix them up and get the question right. Okay. So don't mix up which one is vertical and which one is horizontal. Okay, so a couple things to keep in mind when you're kind of counting or measuring your rise and your run. Right? Yeah?
Can I go back?
Yeah. When you think about horizontal, what are the two directions you can move if you move horizontal? Left, side to side, left to right. Well, in math, if you go left, that means something. If you go right, that means something else. If you go left, that's negative. If you go right, that is positive. So when we're counting rise and run, which way you go is going to change if you count positive or negative. If you count up, like let's look at this one. To get from point 1 to point 2, do you count up or do you count down? You count up. If you count up, that's positive. Let's look at something like this. Point 1, point 2. Rise, run. Look at your run. In this case, to get from point 1 to point 2, does your run go left or does your run go right? It goes which way? To get from point 1 to point 2, which way does the run go? So you're starting here, and you're traveling this way along these lines. Which way is the run going? It's going right. So if this was on a grid and we counted it, we would be counting positives. 1, 2, 3. Okay. Which way does that's the run. It goes to the right. Which way does the rise go here? Down, right? So when you count it, that's going to be a negative number. Okay. How about here? Which way does the rise go? To get from point 1 to point 2. It goes up. Which way does the run go? Goes right. You're traveling like this. Up and to the right. So, moving left and right, that's how you find your rise. Once you find that number, you put it right here in a fraction. Moving up and down, that's how you find your run. Once you find that number, you put it right there in the fraction. Once you write rise over run, you've just written the slope. You just have to find these two numbers by counting on a graph, if you're given a graph. Now, let's say you're not given a graph. Let's say you're given something like this. You can't count here. The reason you can't count is because there's no grid. Okay? So, what I would have to do is give you coordinates. I would have to give you something like, well, here you could actually do it both ways. You've got the grid, so you could count, or you also have the coordinates. You could do it both ways. I'm going to show you how to do it if they only give you coordinates. Okay? So look at this one. There's no grid. So you can't count because there's nothing to count. You've just got to use these numbers to do it. So this is how you do it. This is the formula to find slope. The top is your rise. The bottom is your run.
This looks
right?
complicated.
When you can't count it, when you don't have a graph, you have to use this formula because you don't have anything to count. You're still finding the rise and you're still finding the run. You're just using a formula rather than using a picture. And I'll show you what these values are. There's 4 values that you need to find the slope. 2 of them are used to find the top. 2 2 of them are used to find the bottom. Okay. So, in a problem, if I said find the slope and you had to do it this way, I would give you something like this. Find the slope. And I would give you 4 numbers. 4, 2, -3, 5. Just made those numbers up. So this would be a problem where you would have to use this. First step is to label those 4 numbers. Okay? Label them all. When you write a coordinate, which letter is always first? The X, and then the second letter? A Y. This is an X, this is a Y. This is an X, this is a Y. How many X's did they give me?
2.
They gave me 2. This is an X, this is an X. 4 is an X, -3 is an X. What we're going to do is call one of them my first X, and one of them my second X. These aren't exponents. Right? We're not doing anything with exponents. This just means first X, second X. So something like this. That's the first X. That's the second X. Okay. What's the second letter that they give me? That's always my Y. So this would be the first Y, because it's the first one I see in the problem. This would be the second Y. Once you've done that, that's the hard part. X1 is 4. Y1 is 2. My second X is -3. My second Y is 5. You're going to take those 4 numbers, 1, 2, 3, 4, and you're going to plug them into these 4 spots. 1, 2, 3, 4. So if I was finding the slope in this problem, what number would I plug in for Y2? 5. Minus. What number would I plug in for Y1? 2. Over. The bottom has a minus in it as well. What would you plug in for X2? -3. And Blake, what would you plug in for X1? 4. And that's how you find the slope if you don't have a picture to count. Now you can use your calculator or just simplify that in your head. Do 5 minus 2, and then do -3 minus 4. But that's all you have to do to find slope. It's not that hard of a formula, as long as you remember the formula. Some people mix up where stuff goes. Just make sure you write that down. Okay, so we already did that. I said take the formula, plug in the numbers, just like we did. 5, 2, -3, -4. And then simplify it as much as you can. Now, I said simplify if necessary because how do you know if a fraction can be simplified? Not all fractions can be. Yeah?
If there's more on the numerator than the denominator.
So if you had something like that, you could simplify it?
Yes, because that is an improper fraction.
Okay, so that's different. Improper fractions are okay. In fact, we don't mind them at all.
Never mind.
We don't ever want to use mixed numbers or decimals. But that's not a fraction that could be simplified. Can anyone change this number so then it could be simplified, John?
6.
Sure. That's a fraction that can be simplified. You could write it as 3/2. So simplify just means reduce it, if you can. Right? When it was a 5, you couldn't. When it was a 6, you could. Okay? If we did this top one, what's 5 minus 2?
3.
What's -3 minus 4?
-1.
That's -3 plus 4 would be 1. What's -3 minus 4? -7. Can that be reduced? No. So that would be the steepness of these points. That's the steepness. To get from this point to that point, you would have to go up 3 and right, or actually left 7. up 3, left 7. That's what that means. Because negative means to go left. And we wrote that right here. Negative means left. So up and left. All right, so on your guided notes, last thing before we do an example, you guys have 4 graphs at the bottom. I'm going to show you the 4 different kinds of slope. We're going to draw an example of each one. You don't have to draw the exact picture that I have. Just draw something close. Positive slope. Did anyone remember? I said it earlier. But what does a positive slope look like? It slants how, Stephen? Up. It slants up. Right? It looks like that. So when you have a positive slope, it slants up to the right. It also slants down to the left. You could say that, but usually we say it slants up to the right. So to find the slope, on that part, when you guys, it says to find the slope, count up and right. You don't have to write this down unless you think you need it. I don't think you need that. I think if you have a picture, that's probably easier to see.
Then what do you write?
So you want to just write to find slope, count up and right.
Where do we write that?
You should have a spot right on the bottom.
Oh, yeah.
Right on the very bottom. Okay, but you don't have to write what I circled in green, unless you think you need it.
Do you want to draw the little thingy?
Yeah, draw an example of that line. Okay, just draw something that looks like that.
Like, but it doesn't have to be like exact to you.
No,
what happened to the
anything that looks like this. Anything that slants up.
Wait, what happened to the box thing? Not the box, the rise and run thing that you wanted.
I had it there. I just erased
Do we
it.
need to draw that?
No, you can if you want, but you don't need to.
Okay.
You count up and right. That's how you would do it. If you had a point here and here, count up, count right. Now here I can't do it because I don't have a grid. I don't have a grid, so I don't know. How about a negative slope? How does that line look? Down. It slants down when you go which way?
Right.
This one is down to the left.
I mean, it would be like that.
So yeah, Stephen, you had it. So it slants down to the right. So this line falls as you go to the right. So if you were trying to find the slope here, you would pick a point. You would pick another point. Doesn't matter which two you pick, they're usually going to tell you. And you would count down, and then you would count right. Down and right. So notice you always count right. Always. We either go up and right or down and right. Technically, can you go like the opposite of that? You can go instead of up and right, can you go down and left? Technically, but it's going to get confusing. The only time I would go down and to the left is, let's say I had to draw a graph like this, and I had a point right here, and I'm on the edge of my page, right? I would go down and to the right because I have plenty of room. Plenty. Now, let's say for some reason, here's your piece of paper, and you had a point right there. You don't have any room to go down and to the right now. You're out of room. So you can go, instead of down and to the right, which would be off your page, you can go up and to the left. Okay. I usually don't do that unless I have to. All right. I try to put my graph in a good spot so I have plenty of space. Okay, how about a slope of 0?
It's just a straight line.
Well, they're all straight lines.
Well, like
Horizontal. So on the third one, in the top of the box, you want to write slope of 0. And then you want to write it is horizontal. Now, I didn't write how to find the slope. because this is a special case. Okay? The slope is right here. The slope is 0. You don't have to find it or calculate it. Anytime that you have a horizontal line, the slope is automatically 0. There's nothing to find. There's nothing to count. Okay? And what do you think this one would be? What kind of line? It's another special case.
Undefined.
It's an undefined slope.
I'm
But what kind of line? It is. It's vertical. Because think about vertical. Vertical is so steep you couldn't even stand on it. Right? If a wall is vertical, it's so steep that we can't even describe it. Right? So that's called an undefined slope. So there is nothing to find. If I give you a vertical line and I ask you for the slope, just write undefined. There's nothing else to do. If I give you a horizontal line and ask you to find the slope, just write 0. If I give you a line that slants, then you have to do a little work. You've got to figure out how much it slants. That's the rise over the run. Okay. So any questions on those 4 types of slopes? And that's it. There's no other type of slope. Positive, negative, flat, and vertical. Yeah? Yeah.
So could an undefined slope be horizontal?
No, undefined means vertical. Horizontal is always what number?
0.
0. So vertical lines don't even have a number. They don't even have a number. These are positive numbers. These are negative numbers. This is 0. What other kind of number is there? There's nothing else besides positives, negatives, and zeros. So vertical, there isn't a number. It's just undefined.
So for slope of 0 and undefined slope, there's no like dots?
No, there's no calculation or anything you need to do. The only time you've got to count with dots is this one and this one. And that's where you have to use this formula. Rise over run. Okay, so let's look at an example. Now, in 1a, you've got a choice. You've got an x and a y. You've got another x and another y. So you could use the formula. You could use this. y2 minus y1 over x2 minus x1. I think that's more work. I think when you have a picture, it's a lot easier to just count. So, first of all, in example A, which one of the 4 cases is this? Positive slope, negative slope, 0 slope, or undefined slope? Yep. Positive. So that's the first thing they said to do. Describe the slope. Means just to do one of those 4. So this is a positive slope. Now they want me to actually find the slope. What's the formula for slope? Using those 2 words. Blank over blank. Yep. Rise over run. Rise is which way? Okay? Up or down. In this case, it's going to be up. And run is which way? Left or right. So let's start at this dot and count to that dot. Okay? Remember, I always either count one of 2 ways. Up and right or down and right. I never count left. It's going to confuse you. Always go up and right or down and right. So let's go up. 1, 2, 3, 4, 5. I went up 5. Is that a positive or a negative? Positive. That's my rise. How many do I have to go to the right? 1, 2, 3, 4, 5. So there's your rise. Up 5. There's your run. Right 5. Now, reduce that if you can. What's 5 divided by 5? 1. That's the slope of that line. 1.
Is the slope description like the rise over run?
Yes. Slope is rise over run. Now, look at B. You shouldn't even really do any work here. What kind of line is that?
Undefined.
The slope of 0.
Undefined.
Why is it a slope of 0?
Because there is no slope.
Well, what kind of line
It's
is it?
horizontal.
It's horizontal.
What?
Yes.
Oh, never mind.
So
30 minutes.
horizontal line, slope of 0. So how do you describe the slope? Well, you just say slope of 0. And there's no other calculation there, right? By describing it as a slope of 0, you've told me the slope. Okay? There's only extra work to do when it slants. Okay, so under slope description, just write slope of 0 for both. Slope description, slope of 0. Slope, actually you could just put the number 0. That's even shorter. On part A, positive slope, and then under slope, put the number 1. Okay. Let's look at example 2. Yeah. Yeah. Describe the slope. Same thing we just did. Who can tell me what kind of slope that is first? Aileen?
Negative.
Negative slope. So on the line that says slope description, you want to put negative slope. Now, what are the two ways that I said to always count? Either the directions.
Down and right.
Down and right, or
Up and right.
up and right. Don't ever go left. Unless you have to. Don't ever go left. So we're going to start here, and we're going to end here. How many down do I have to go? 1, 2, 3, 4. Now I went down 4. When you go down, what kind of number is your rise?
Negative.
Negative. Down 4. Now, 1, 2, 3, 4. How many to the right?
3.
1, 2, 3. When you go to the right, is that positive or negative?
Positive.
That's positive. And there's your slope. Can that be reduced?
No.
No. If it was negative 4 over 2, I would say yes. Negative 4 over 3? No. And that's, so where it says slope description, put negative slope. Where it says slope equals, put negative 4 over 3.
Is it possible for the denominator to be negative?
Not if we're counting to the right, no. The negative will always be in the top. Okay? As long as you count up and right or down and right. Yeah. Let's look at 2b. What kind of line is that?
Undefined.
Well, what kind of line is it first? Vertical. And what's the slope of a vertical?
Undefined.
So where it says slope description, you could just say undefined slope. Then where it says slope, you would just say undefined. It's like really the same thing twice. Okay, the horizontals and verticals, you really can write the same thing twice. The slant, you got to do a little extra work. Okay, so any question on how to get slope looking at a picture? We did every case. Positive, negative, 0, undefined. Did one of each. Okay, so now, you guys already have this formula, so you don't have to write it again. I'm just reminding you. That's the formula we're going to use in the next problem. If you are given a table, like I'm going to give you in this problem right here, all you have to do is pick any 2 points you want in that table. Doesn't matter. Any 2, and plug them into that formula. I would pick the easiest 2 that you can. So let's write down the formula first. Can someone remind me what's the formula to find slope when you don't have a picture? Yeah.
Y equals mx. That's my equation.
No, yeah, I think you're thinking of something else.
Yeah.
We'll finish with that in a minute, but you're thinking of something else. Yep.
Would it be x1 or y1 minus x1?
Y2 minus Y1 over what goes in the bottom? X2 minus X1. Now, how many numbers do I have to plug into that formula? Lucas? I got to plug in 4. So pick any 2 points. 2 comma 1, that's a point. That's an X, that's a Y. 3 comma 0, that's an X, that's a Y. You can pick any 2 that you want. Somebody give me one coordinate that they want to use in that table. Doesn't matter which one you pick. As long as you do it, the math right, it's all going to come out the same.
2 and 1.
All right. So we're going to use that one. And somebody give me one other coordinate you want to use from that table.
3 and 0.
3 and 0. I think 0 is a good one. Anytime you get 0, it's going to make the math easier. Okay. Is 2 an X value or a Y value?
X.
It's an X. Do you want it to be my first X or my second X? Doesn't matter.
First.
First X. Is 1 an X value or a Y value?
Y.
It's a Y value, and it has to be your first Y, because you made that one your first X. 3, is that an X value or a Y value?
It's X.
Can it be my first X?
Yes.
No,
No,
because the other one is the first.
Alrighty, you made the other one my first X, so that has to be
2.
my second X.
X.
Is 0 an X value or a Y value?
Y.
Can it be my first Y? No, I already picked something for my first Y, so what does it have to be? It's got to be my second Y. Now that's the hard part. Now just plug those numbers in and we'll have our answer. Go like this first. Always set it up like that. And now fill in the 4 spots. Kayla, what's Y2? 0. Blake, what's Y1? 1. How about Princess, what's X2? 3.
How are you getting this?
We're just copying these numbers from this table. We're copying these 4 numbers into these 4 spots. So what's X1? About Joe?
2.
2. Now we simplify. What's 0 minus 1? Negative 1.
1.
And what's 3 minus 2? 1. And what's negative 1 divided by 1? Negative 1. So this is a line with a negative slope. Okay? Negative slope. Yeah.
Does that mean that there can be more than one answer?
No, doesn't matter which 2 you picked. No, if you picked, say, the second column and the third column, you would have gotten the same answer. Yep, these are always going to be set up no matter which 2 you pick, everybody will get the same answer. So pick the smallest numbers. I think that makes it the easiest. Okay, let's look at this one. Somebody tell me one column that they want to use. You got 4 choices. Mike?
5 and 0.
Okay. So we're going to use that one and pick one other one. Doesn't matter.
2 and 1.
I think 2 and 1 is good. That way we can avoid negative numbers. Let's start with 2. Is that an X or a Y?
X.
Do you want it to be the first or the second?
The second.
The second? Okay, we can do that. Is 1 an X or a Y? It's a Y, and what does it have to be?
Second.
It's got to be the second, because they go together. If you make the top one the second, you got to make the bottom one the second. 5. Is that an x or a y? It's an x. First x or second x? We're calling it the first x. That's fine.
Wait, does it matter which
Nope.
is the first and second?
Doesn't matter. How about 0? X or y?
Y.
First or second?
First.
We're calling it the first. So now, let's look at our formula. What's y2? What is it? 1. Minus, what's y1? 0. Over, what's x2? 2. Minus,
5.
x1 is 5. Yep, perfect. What's 1 minus 0? 1. 2 minus 5? And that's your slope. It's okay that the negative ended up in the bottom. If you said, well, could I put the negative in the top? Sure.
Can you have?
It's exactly the same thing. Exactly the same thing. It doesn't
Wait, so
matter.
you can put the negative sign on either number?
Yep, when you're reducing it like that, it's the same thing.
Like,
I usually put it in the top.
on all of them or just like this one? Like this equation? Like
Anywhere.
one-
Yep, anywhere you have a fraction that has a negative, it makes no difference if it's in the top or the bottom.
So this is the
That means this one has a negative slope. Yep, it would slant down. If you were to draw it, it would look something like this. Okay, any questions before we look at the last one? Okay, so let's finish up with this. Might have already mentioned this earlier, I think, at some point, but slope-intercept form. So on the bottom of your notes, where it says slope-intercept form, you want to write y equals mx plus b. When you write it, try to make sure that the m is pointing to slope and b is pointing to y-intercept. So that is called slope-intercept form.
Did we write that down?
I think it already says it above the box, so you don't need to write it again. But just copy down this. Y equals mx plus b. So, what I want you to remember is the number in front of the x is your slope. The number at the end, without the variable, is your y-intercept. Now remember, you guys did this on the test last week. You may have to rearrange your equation to get it in y equals mx plus b form. I might give you something like this. Is that y equals mx plus b?
No.
No. Y equals means the y is alone. How would you get rid of this negative 2 and put it on the other side?
Add negative.
Yep.
Add negative 2.
Add,
No, add 2.
add 2. And you get this. What I'm going to ask you now is to look at what's in that box and tell me the slope and tell me the y-intercept. What's the slope of what's in that box? What is it? 3. It's the number next to x. And what's the y-intercept?
2.
2. Right? That's all we're going to do in the last question. But you may have to get the y by yourself first, like we did here. Okay? So, let's look at this one. Is A in y equals mx plus b form?
Yeah.
Then that's the easiest kind of problem you can have. You don't have to do anything but write 2 numbers. What, and they're just numbers. I shouldn't see any letters on these lines. What is the slope?
3.
3. Just 3. Don't write x. X is just there to say, hey, the slope is in front of me. There's your slope. What's your y-intercept?
4.
Negative 4.
Negative 4. Remember, the sign goes with it. If it's a plus, it's a plus. If it's a minus, it's a minus. Okay, so y-intercept is negative 4. Okay, how about this one? Is that one y by itself?
Yes.
Yeah, y is by itself, but there's no b. So if you wanted to put it in, what is it? What do you think b would be here?
0.
It's like 0. So if you want to add that in, you can. I'm not going to do that on the test. On the test, it's going to be written like this. So what's your slope?
-2.
Your slope is -2. Do not write a letter. And what's your y-intercept?
0.
It's 0. Exactly. Okay, question on that one? Let's look at last one, C. Is that y equals mx plus b? No. This one's a little bit more work. What do I have to do to fix it? Add what?
3.
Add 3 to both sides. When I do that, what's on the left side now? That's exactly what we want. Why? What's on the right? 1/3 x plus 3. Now you should be able to tell me the slope and the intercept. What's the slope? 1/3. Yeah, anytime we write slope, we'll usually do it as a fraction. So 1/3.
I don't know why I said 20.
And what's your y-intercept?
3.
3. Perfect. So that's slope y-intercept. Okay, so on tomorrow we will finish this up. Okay, so homework tonight, worksheet. Remember, no class on Thursday. So I will see you guys tomorrow.